Okay, we're back, and this is our Introduction to Statistical Tests, Part 2. And you were going to flip a coin 25 times or use the random coin flipper to do 25 times. I did mine, and I got 16 heads. So 16 out of 25. And then we want to know, I actually already calculated it, but let me show you how I did it. So we want to know what proportion of heads is that. And that's really like a percentage, but it's the decimal version of a percentage. So I did 16 divided by 25, and you can do this with your number. So go ahead and however many heads you got, divide that by 25 and write down your decimal. So I got 0.64, and that's our proportion. Okay, so how does that seem? Well, obviously it's possible because we got it. And, 50, the coins are 50-50. So we could get anywhere, a little bit below 50% to a little bit above 50%. And that, that seems logical, right? So now we want to compare this with a class result. So this video is recorded in advance, so I don't have our class results tabulated yet, but I will share those with you since some of you are just doing the survey. But what I did was I took data from a previous class. And in that class, the number of students who said booba was the rounded shape, or the one on the left, is 18. Okay, so I'm going to calculate that proportion, and that's 18 out of 25. I want to see what that's going to be. That's 72%, or 0.72. Okay, so do your results seem very different from mine? We want to compare our, just assuming it's random, with the actual people associating the word and shape to see, is there a significant association? Now 72% is higher, so I wonder, how often would we get something this high if we did these 25 coin flips over and over again? So that's what we're going to do. We want to know whether this class result could have happened by chance. So whether the class result could have happened by chance. Or the other option is, or there's a significant association between the words and shapes. Okay, so to investigate this, we're going to flip 25 coins many times. So not just one time to see I got 64%, but we need to do it many, many times to see what happens in the long run. Okay, so we're going to use a lot of simulations in this class. So we're going to show you this the first time. So how the simulation works is we're going to flip 25 coins many times so we can see what the range of reasonable values are for a 50-50 choice. Okay, now this would take a long time and get very tedious if we were to flip 25 coins many, many times physically. So we're going to do a simulation. And even if we were to use random.org many times, that would get pretty tedious as well. So there are applets specifically designed to do this. And again, each applet we use in a video should appear, the link should appear right before that video, so you can open it up in advance or whenever you want to do it. But it's helpful to do this along with the video so you get the practice. So I'm going to switch over to this Rossmann chance one proportion. I've got it right here. Oops, I forgot to clear it out again. Let me go to a new one. I was practicing with it before. So we're going to one proportion inference, and this is what it looks like when you come up with the blank applet. Okay, so we put in our probability. In this case, we are doing a coin flip, which is 50-50. We can change that to something 40-60 or so. If there's a different probability. Now, instead of 5, we are going to do 25. Remember, it's for each person in the class. And we're going to do one repetition to start with so I can show you how it looks. And then you want to be sure show animation is checked so you can see the coins. And when I hit draw samples, it's going to flip 25 coins. It does take a minute. Okay, great. So you can see the coins, all the coins up at the top, and then it separates out and counts the heads and the tails. And I want to see if it'll give me, okay, it doesn't give me the exact proportion. Let me move this up so you can see the rest of the graph here. So it did 10 divided by 15. Let me do that real quick. And that's 2/3. Yeah, it's 2/3, 0.67. So on the graph, it drops down. Now, right now it's set to number of heads. So number, or else it's also called count. You can see it's set at 10. But more often we'll use the proportion because it's easier to understand relatively what's going on versus a number like 10 out of 25. I'm not always sure what that is, or what if it was 10 out of 57. So I'm going to switch that to proportion. And you can see... oh, sorry, I did 10 out of 15. I know that didn't sound right. 10 out of 25 is 40%. Okay, so 40% is right there. Okay, so then if I do it again, let's do one more like that. Wow, you can see it came up 10 again. So I don't know how likely that is to happen the same exact thing twice in a row, but it happened. Okay, now I want to do it some more, but I'm going to uncheck show animation because it takes kind of a long time. And you'll see if I hit draw sample again, now it just shows the picture. And now we got 13 heads out of 25. I'm going to do a few more of those. And you can see that each sample of 25 is one dot on this dot plot here. This graph is called a dot plot. I'm going to keep going. I'm going to go up to 10. Okay, so you can see it as expected, it's not going to be the same every time because we have this element of chance, of randomness. It is an interesting looking shape though. So now we want to get a better sense of the long-term behavior of this. So how likely is that 0.72 to happen? We still haven't gotten one that high, but we've only done 10 trials. So most often in general, we're going to use 2,000 trials. So since I've done 10, I'm going to do 1990 to get up to 2,000. If I did 2010, it's not that big a deal, but I'm just going to go ahead and make it so they add up to 2,000. And then here we have 2,000 total repetitions, and look at the shape of this graph. Does that look familiar to you? You might have seen that bell-shaped curve or normal shaped curve before. Okay, now I see it is possible to get 0.72. In fact, that was this last trial here just happened to be 18 out of 25. But how likely is it? Like, is it more likely that it happened due to chance, or is it more likely that there's an association between the words and the shapes? Okay, now we can actually quantify this. We want to know how many times did that happen? And we can think of that as a probability. What percentage or proportion of times did that happen? So I want to know, and when I hover over this, it says enter observed statistic. So the observed statistic is from our survey, 18 out of 25 times, or 0.72. And when I click on count, it will tell me, and it'll show me in red right here. So it actually happened 48 times, that 0.72 or more, that we got that. So 48 out of 2,000 is around 2.5%, 0.0240 or 2.4%. Okay, so it's possible, but is it likely that we would get that kind of answer if there was no association between the words and the shapes? Not really. So we often use a guideline of 5%, and this is under this 5%. So let me go back to the notes here. And you'll see I've got a couple screenshots on here, so you just have the reference. In the notes, here's one with just the first coin flip and what I typed in. And then I also, even though it labels proportion of heads, I like to make this more specific because it helps us remember what we're doing. And it is kind of abstract, so it helps us just conceptualize what's going on. So instead of just proportion of heads, I've changed it to proportion of heads in samples of 25 coin tosses. So that way we know every single dot is 25 coin tosses, and then what percentage or what proportion of heads did we get? Okay, so then on the next page, you'll see another screenshot. So let me put this up here. And this is what we did. So we put in, we kept it 50-50, 25 tosses. We had 2,000 repetitions. And that time I got 52 out of 2,000, so about 0.26. And I kept my more specific title here. So as you're doing it, you'll see that you get a different answer as well, right? Every time we do it, we'll get a different answer because there's that element of randomness, and that's just normal variation. Okay, so what can we conclude from this simulation? Is our result of the 18 out of 25 or 0.72, is that statistically significant? And so first let's talk in general. A result, go back to my green, a result is statistically significant if it's unlikely to occur just due to random chance. If it's unlikely to occur just by random chance. Okay, and we often use, we'll learn more about this in detail, but we often use 5% as a guideline for that. If it's less than 5% chance of happening. Okay, so let's write about our class results. So our class result, or the class result of 18, because it is a previous class, 18 out of 25, which is 0.72, is unlikely to happen due to chance. And then we always want to write our conclusion in the context of the study, so that we can bring people back to what we were talking about, and so that it makes sense. So we could say, so there is evidence. We always talk about the evidence. That there is a significant relationship between these shapes. Or actually, I would like to say between the word booba and the rounded shape. That's the association, because more people, 18 people, said booba was the rounded shape and kiki was the pointed shape. So there's a relationship between the word booba and the rounded shape, and the word kiki and the pointy shape. Okay, so it turns out this is repeated. This has been researched in detail, in depth, and there is a relationship. So if you'd like to learn more about it, I put this as a short video about it, and I put that next. That's optional. And then there's also a research article. I also put that in D2L. There's a research article, and here they really studied across cultures and different languages with different writing systems. That's the language connection I was talking about, and it does hold up. So I hope you've enjoyed this introduction to statistical significance, simulation and testing, and some vocabulary. Thank you for watching, and I'll see you in the next video.